Hello you everybody who is watching this fantastic video, and I would like just to welcome you into this fantastic moment. My name is Olenjolaim from beautiful country, United Republic of Tanzania. I'm very happy to have you today, whether you're a national or international viewer. I'm very happy to welcome you into this fantastic moment when we are going to teach you in such a way that we can take you or we can transform you from the point where you are to the next point. So I would like just to give you a quick introductions before we go into today's lecture. And I would like to take this opportunity right now to welcome every international and national viewer, whether you're a student or you're a teacher or you're a lecturer or you're a tutorial assistant or you're a parent. Okay, I would like to welcome all of you into one of our online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI. And simultaneously, I would like to welcome you into one of our YouTube channels that's called Online Diploma Polyinstitute of Tanzania in square bracket OLENJOLAI. Well, so the question, you might be having so many questions concerning about these programs if it's your first time. Well, that's how the human being we used to be. And it's good to ask yourself so many questions once you meet anything new in your mind. So one of the basic questions that I know you are asking yourself is what the vision that we have in Online Diploma Polytechnic Institute of Tanzania. Well, so we have an assignment to teach, train, incubate some ordinary diploma students who are well prepared or who want to be well prepared to be competent basic technicians or technicians in engineering and scientific fields, because we are not covering every kinds of the field. So we have an assignment to teach and train them how they can extract knowledge and wisdom from the informal or informal educations of ordinary diploma in engineering and science courses, and combine with the knowledge and wisdom from the Word of God that is written in the Holy Bible in order to solve a real life problem. So our main objective in Online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI is to see our continuing and even our graduating students who are capable to solve a real life problems, because there is a real life problems that waiting you to solve. So that the visions we have, and that the main objective of this program. However, that we'll be spending some times on helping you on getting at least on training and teaching you concerning about how you can master your continuing assessment, how you can go through it, and even how you can get prepared for your final exams. So all of those, we call them specific objectives. So we have so many specific objectives that we're trying our level best to make sure that we achieve them. Okay, so after having such a piece of information, which is very important, I would like also take this opportunity to welcome you into one of our department, which is called Basic Engineering and Scientific Mathematics. So the modules of the course that we have today, or we are going to discuss, is called Conics and Differential Equation. And then we are in topic 5, which is called Differential Equation. And this is lecture 2, which I'm going to teach about the order of differential equation, degree of differential equation, linear differential equation, and non-linear differential equation. Well, I again would like to invite you to be a part of this program, so you can participate these programs in different ways. But one of the ways that we can offer you free will in Thanksgiving through the online, through the actual wireless transactions, which you can do your transaction. You can send your free willings Thanksgiving offerings through this telephone number 0759745331. But again, this course is because of modules it has been taught in Tanzania and even in many institutions, colleges and universities in the world for the third year students, which we call NTA level 6 ordinary diploma. So this is NTA, means National Technical Award level 6. So you have level 4, level 5, and level 6. Level 4 is first year, level 5 is second year, and level 6 is third year ordinary diploma. So another piece of information that we'll be sharing, the very important contents which have been prepared in order to help ordinary diploma students to master different aspects of their area of interest. So you'll find that this is the helpful. It's online. We don't have any physical institutions. This is the online institution. So we are expecting to train serious students, and even for those who are serious students, we train them on how they can be serious. So take your pen right now, take your scientific calculator. Another thing that also we have an online library in online Diploma Polytechnic Institute of Tanzania. And in this online library, we are providing also some of the essential contents or essential reference books and materials, for example, the scientific calculator, in order to equip our ordinary diploma students so that they can do great things in mathematics, in science, and engineering for the rest of their life. So you have to stay tuned. I will give you, means that you have to read the descriptions below for you to get the information how you can order materials and materials online that will be useful for your studies. So now let us go to the today's sessions. As I said, that I'm going to start to give you the quick review of lecture 1. The lecture 1 has been titled as General Introductions of Differential Question. So firstly, I define the terms calculus, because in calculus we get this terminology of differential question. And then, as I mentioned, 3 branches of calculus. The first one is called differentiation, the second one is called integration, and the third one is called differential equation. So we consider this differential question. Again, I told you about what the meanings of differential equation. So I define differential equation. I said a differential equation is an equation which containing dependency, we say that differential equation is an equation which containing differential coefficient and its variables. Okay, it's variables. So we can have a single variable differential equation and multivariable differential equation. So if you do remember that we said we classified also, we have 2 types of differential equation. The first one is called the ordinary differential equation. So here we say that you have single dependent variable, just to remind you, single dependent variable, and also you have single independent variable. So you have also single independent, so this is single dependent variable, also you have single independent variable. Okay, just to remind you, I gave the example that we say we can have y double dash and then say y single dash plus 2y, this is equal to 4x. So this is the ordinary differential equation. So an example of ordinary differential equation. Again, I taught you, or I introduced you about partial differential equation. And I insisted you that you have to make sure that this concept, you keep this concept, because you need it even in your undergraduate education. So you say the partial differential equation, we formulate these partial differential equations, or it's a partial differential equation that we formulate from what? From multivariable function. So the multivariable function, it has what? Single dependent. So single dependent variable. In most cases, it is u, single dependent variable. So this is single dependent variable. Okay, single dependent variable. So it has single dependent variable, example u, that's a common one. And also it should have more than one independent. Okay, should have more than one independent variable. So for example, you can find x and y, or you can find xz, xyz, or you can find xyt, etc., etc. So then I gave you examples. So example of partial differential equation, just to remind you, we say that we can have a partial differential equations of this type. Partial derivatives of u with respect to partial derivatives of y, then minus 4 partial derivative of u, partial derivatives of x, then plus 4y, this is equal to e power x. So these are the examples. So that's what I taught you and build the foundations in lecture 1. So today, let us take into the next level. Let us keep on building the foundation to state the foundational concept. So let us start with in today's lecture, where I want to teach you about order, say order, order of differential equation. Remember that I told you in this course, differential equation, order of differential equation. In this course, differential equation, order of differential equation. So I told you that in this course, we are going to focus on we have to teach you only ordinary differential equation. So when you get into undergraduate educations, then we are going to teach you about partial differential equation. So when against this topic, whenever we mention differential equation, we don't mean both ordinary differential equations and the partial differential equation, but we just mean one type, which is what? Ordinary differential equation, right? So the fundamental question that we have here on the spot, this will be question number 1. What is order of differential equation? What is order of what? Of differential equation. What is order of differential equation? What is order? What is the meaning of order? So what the meaning of order of differential equation? So this is the question that we have on the spot. So the answer is, you can pause the video and try on your own. Order of differential equation, okay, which we can use just in abbreviations of DE. Okay, so you say that this is the highest, say highest, this is the highest derivative, ordinary derivative, okay, highest derivative present in the differential equation, So this is the definitions of order of differential equation. Order of differential equations, what is it? Is the highest derivative, only one. In every ordinary differential equation, we expect to find one highest derivative of what? Which is present in differential equation. What does it mean? So as we say that the differential equation containing function and the ordinary differential equation containing a single variable function and what? And differential coefficient, and also it contains differential derivatives. Okay, so we say that this is the highest derivative present in the differential equation. What does it mean, the word highest? It means that we can have more than one derivative, but only one will be the highest derivative. All right, so let me give you examples. Okay, so examples. So the first example, remember the notations that I told you, that you can have first derivative dy dx minus 4y, this is equal to 0. So this is, we call it first order. So we just write this in mathematics, first order ordinary differential equation. Why it is first order? Because the highest derivative in this example is first derivative. Then we can have the second example. So we have again another notation. So another notation, you can have maybe y single dash minus sine of x y is equal to what? Is equal to e power x. So again, this is first order. So this is first order differential equation, because the highest derivative is only the first order, only the first derivative. So the same example, we can also have second derivative dy dx square minus 4 dy. So right now, in example 3, we have more than one derivative, or more than one derivative, and then plus what? Plus 3y is equal to x squared. So right now, this one, it is what? Second order ordinary differential equation. Okay, second order ordinary differential equation. Okay, so again, we can have another example. Okay, so example 4. So example 4, we say that we can have maybe in this format that we have y triple dash, then we have y single dash, double dash, then you have plus 2y single dash, then plus 3y is equal to sine of x. So this is what it is, third order ordinary differential equation. Why is it third order? Because the highest derivative present in this differential equation is what? The third derivative. However, that here we have this is the differential this is the derivative, a differential derivative, differential derivative, differential derivative. This is the function, and this is the function, right? Here, dependent variable is y, while the independent variable is what? It's x. So you can have again more examples that give you the, you can have also the y, the x, but here we have 6 power 4. Then minus what? Minus second derivative, the y, the x square, like this. Then we say that plus what? Plus 6y is equal to what? Is equal to x minus 2. So if you examine how many differential derivatives we have there, well, we have two differential derivatives. First differential derivative, second. And then what is this one? This is the first order, but it has been raised with a certain degree. This is the second order. So between first order, between the first derivative and second derivative, which is the highest? The highest is the second derivative. Why? Because the first derivative is less derivative compared to the second derivative. And second derivative is less derivative compared to the third derivative. Means the third derivative is the highest derivatives compared to the first and second derivative. The first derivative is the highest derivative, our highest differential derivative compared to the third differential derivative, second differential derivative, and first differential derivative. So for this case, regardless of this highest degree that appear in this first differential derivative, this is still the highest derivative. So for this one, if we classify now, because we'll be asked that to classify, we say that is what? So this differential equation, it is what? It is second order ordinary differential equation. Okay? It's the second order ordinary differential equation. So you see that how this stuff are very interesting. Differential equations is the one of the beautiful topic of conics and differential equations of this module. So I think that those are these examples are enough for you to understand the concept of order. So remember that what I've been teaching you for several minutes is I've been teaching about order of differential equation. You have to bear it in your mind. You need this concept during your ordinary diploma studies, and you need this concept you want, but against that in your undergraduate studies, because we have to refer this concept because we won't teach you further against about order unless that we can remind you because we have taught you. So that's all about order of differential equation. So it means that because I'll give you the quiz, it means that the homework. So let me teach you right now, ladies and gentlemen, about degree. Say degree. It doesn't mean the bachelor degree. Degree of ordinary differential equation. I'll be preferring to use the abbreviations. Degree of what? Ordinary differential equation. So the fundamental question, which will be question number 2. Do you enjoy the beauty of basic engineering and scientific mathematics? So the second question is, what is degree of ordinary differential equation? That's a question mark. You can pause the video and then ask yourself and take a piece of paper and try to answer these questions on your own. And hence you continue on watching the video until that this concept has been built in your mind. So what is the degree of ordinary differential equation? So well, we say that degree is the, okay, so we say that in the degree of differential equation, we say that the degree of differential equation is the power to which the power to which the ordinary ordinary, to which the highest ordinary differential derivative, the highest ordinary, or simply we call it differential derivative, okay, the highest ordinary differential derivative, okay, derivative appear. So simply this is the power. So the power to which the highest ordinary differential derivative appear in ordinary differential equation. So this is the way that we can define the degree. So degree is the power of what? Is the power to which the ordinary, to which the highest differential derivative, the power of the highest differential derivative present in the ordinary differential equation. So this is the one of the way that you can define the term degree of differential equation. But also you can define these terms of degree of differential equation as is the highest power of the highest differential derivative which the equations contain, or can define as is the highest power, is the highest power of the highest derivative of the highest differential of the highest differential coefficient, the highest differential coefficient, which the equation contains, which the ordinary differential equation contains. So that's the meanings of the degree of differential equation. So it's the highest power of the highest differential coefficient. This is the highest differential derivative. In some of the books we call it coefficient. So use the word coefficient and the word coefficient and derivative interchangeably. So I want to avoid confusion because I classify to you what the meanings of coefficient and what the meanings of what derivatives and what the meanings of differential derivative. Okay, so let me give you examples of of degree of differential equation. Differential, ordinary differential equation of ODE. Okay, so I will give you an example there and then we'll state the degree. So the first example is this. We have the second derivative and then plus the first derivative, but this is power of 2 plus 4y is equal to 0. So first of all, is this a partial differential equation or ordinary differential equation? The answer is ordinary differential equation. Why? Because it contains a single dependent variable and single dependent variable. The next question, can you classify the order of this equation? Yes, because I told you this is what second order differential equation, because the highest differential derivative present in that differential equation is what is second derivative. Then now we come to the degree. What the means of degree? Degree is the power of the highest differential derivative present in the differential equation. Remember that. So what the degree? So where is the highest differential derivative? This is the highest differential derivative. So this is the highest differential. This is the highest differential derivative. So this is the highest differential derivative. So what is power? So its power here, it's 1. So then this is we say it's a second order, or it's a second order ordinary differential equation of the degree 1. So simply the degree of this equation is what? Is 1. So we just write this one, that it is what? It is second order ordinary differential equation of degree 1. So the degree, we don't use this first, second, third, fourth, fifth, sixth, seventh. We don't use that terminology. So the degree, we just use the normal numbers. 1, 2, 3, 4, 5, etc., etc. But in case of the order, we used to mention the order by using this special way of counting as first or second or third or fourth or fifth or sixth, etc., etc. And the rest of the derivatives, we call them, or of the order, we call the highest order differential equation. So let us go to the second example. So second example, we have y double dash. And then we say that we have plus 4y. This is equal to e power x. What the highest derivative there? The highest derivative is what? Is this one, which is the second order. So it means that what the power? Its power is 1. So this is what? So you say it is second order ordinary differential equation of degree 1. So again, we can have another derivative. So now we can have dy dx minus 4y is equal to x. And then this one now, it is 4. So what is this? A partial differential equation, ordinary differential equation? This is what? This is ordinary differential equation. Is it first order, second order, third order, fourth order? It's first order because the highest derivative is the first derivative. Then what the degree, what the power of the highest differential derivatives are present in this differential equation? The power, it is 4. So this one, we say that it is first order ordinary differential equation of degree 4. Then we go for the first example. First example, we have y triple dash, and then we have 4, then we have y double dash, then we have power 3, then we have plus 4y is equal to x square minus 3x plus 1. Okay, so let us classify. It is differential. Is this partial or ordinary differential equation? It is what? It is ordinary differential equation. What the order of this differential equation? It is third order because the highest derivative present in that differential equation, it's the third order, which is this one. And then what the degree? Okay, the highest power of this third differential derivative is what? Is 1. So its degree is 1. So this one, we say that it is what? Third order ordinary differential equation of what? Of degree 1. So this is how we classify differential equations, and it's a very important part. Let me give you the last example, then I will teach about linear and non-linear differential equation. Okay, so the last example that we can have also a problem like this one, dy dx, and then this is power 2, then we have again dy dx, then this one is power 3, then minus 4y is equal to e power x. So it is a partial differential questions, ordinary differential question. The answer is ordinary differential question. Why? Because there's only one dependent variable and one independent variable. Again, it is what the order of this differential question. So to identify the order, you have to check the highest derivative. Here we have the highest derivative is first order, so it's the first derivative, and this is third derivative. So let me do minor correction. So here we do have 3. Okay, we do have 3. Okay. So the highest derivative here, it is third derivative. So this is the function and this is the function. So this is the one that is going to decide what is the order of differential question. This one. This is the one that's going to identify the order of differential equation. Okay. So this is what. So we say that it is third order ordinary differential equation of degree 3. So that is, so it means that I believe here I told you, I used the 5 examples to teach you the concepts of the order of differential equation. Here I used the 5 examples to teach you about the concept of the degree of differential equation. So I believe that now you have understood. In case that you find some difficulties on classifying the differential equations about the order and the degree, please don't hesitate yourself to ask me in the comment section. Then I'll try my level best to make sure that I help you or I assist you. So right now, ladies and gentlemen, I believe that you have understood the concepts of order of differential equations and the concept of degree of differential equation. I'd like just to take you now into a very interesting and a little bit challenging part of general introductions of ordinary differential equations at the subtopic that we are covering. And this part is called the linear differential equation and non-linear differential equation. So remember that most of the questions in this part, they used to ask you to classify the following ordinary differential equations in terms of order, degree, and linear and non-linear. Later on, you can teach about it means that homogeneous differential equation, non-homogeneous, but that is in case of the partial differential equation. We'll teach you in the second modules of the second semester of your first year of undergraduate studies in engineering or science. So ladies and gentlemen, allow me right now to teach you about the linear and non-linear differential equation. Okay? So allow me to teach you about the concepts called the linear and non-linear differential equation. Okay? So we're going to cover the concepts called linear and non-linear differential equation. Linear and non-linear differential equation. Say it with me. Linear and non-linear differential equation. Linear and non-linear differential equation. Linear and non-linear differential equation. Linear and non-linear differential equation are the concept that I'm going to teach you right now, ladies and gentlemen. I'm going to teach you what? Linear and non-linear differential equation. Very important. It's very interesting. It's one of the hardest parts for this first subtopic of differential equation. So you have to listen, but I will try my level best to use a very simple language so that you enjoy the contents and you will remember all of this stuff for the rest of your life. So join me right now when I'm going to break down the concepts of linear and non-linear, because there are 3 conditions that govern us on classifying. So linear, say linear, or sometimes some of the books, they used to mention linearity and the non-linearity. So linear and non-linear, linear and non-linear ordinary differential equation, because you can also have non-linear and linear partial differential equations, which is PDE. So ODE is ordinary differential equation. So you say that for any differential equation, to be classified as either as linear ordinary differential equation, then it has to obey all of the following conditions. All of the following three conditions has to obey. Otherwise, the differential equations is classified as linear, right? So you say that for any differential equation to be classified as linear ordinary differential equation, then that differential equation it has to obey all of the following three conditions. Then non-linear, we define them firstly. Non-linear ordinary differential equation is the equation which disobey either of this, either or all of this, either or all of these conditions. Of these three, me correcting, this is plural. Of these three conditions. Okay, ladies and gentlemen, I mean that for an ordinary differential equations, we as engineering mathematicians, we can classify that a particular ordinary differential equation is linear if that ordinary differential equations obeys all of the following three conditions. If it disobeys either one of the following conditions, or two of the following conditions, or all the three of the following conditions, then that differential equations we classify it as what? Non-linear differential equation. Did you get a concept? So you have to listen carefully. So then now, ladies and gentlemen, we say that three conditions for ordinary differential equation to be a linear differential equation. A linear ordinary differential equation. The first condition, then I will give you a simple example. That will, I mean that I will show you the obedience and disobedience of these conditions. Okay? Okay, three conditions for ordinary differential equation to be classified as linear ordinary differential equation. The first one, we have to start from the variable, right? So you say that the highest power of any dependent variable present in the ordinary differential equation must be 1. the highest power. So remember that in this session or in this lecture, we mentioned so many terms of highest power. The highest power of any dependent, not independent, any dependent variable present in the ordinary differential equation should be 1. So for any differential equations to be a linear ordinary differential equation, then the highest power of any dependent variable, for instance, for example, y, should be 1. If the highest power of any dependent variable is not 1, then that differential equation is classified as what? Non-linear differential equation. So right now, let me give you an example. Okay, so you said that otherwise, so let me add otherwise, the ordinary differential equation is classified as non-linear ordinary differential equation. So example 1. So you can have this differential equation that y double dash minus 4y single dash and then plus y is equal to x squared minus 3. So if we examine this differential equation, this is the second derivative, this is the first derivative, this is the function y. So the dependent variable here is y because it's the one that we have differentiated, and this y depends on x. So it means that do we have the first equation? You have to ask ourselves, do we have any dependent variable in this differential equation? Yes, we do. Where is it? This one. Okay, so this one. What the highest power? The highest power of this dependent variable is 1. So therefore, we classify this as what? It is linear ordinary differential equation. Yes, of what? So we can also remember the concepts of order and the degree. What the order of that differential equation and what the degree of that differential equation. And then, did that differential equation obey the first condition? So for the obedience, yes, it's obeyed because the highest power of the dependent variable is 1. Right? So we say that if we classify this differential equation, we say that it is what? First of all, what the highest derivative? It is 2. So it is second order. Is it linear or non-linear? With respect to the first condition, it is linear, right? So we say that it's second order linear ordinary differential equation. It is second order linear ordinary differential equation of what the degree, because I told you also about the concept of the degree. What the degree? What the degree of that differential equation? The degree is what the degree, the highest power of the highest derivative. So the highest power of the highest derivative here, it is 1. So of degree of degree 1. So remember that just to classify the order of differential equations is just repetitions, I taught you. And also classify the degree, also I taught you. And then, so what we are concentrating here, whether the differential equation is linear or non-linear with respect to the mentioned condition. So I have example 2. So example 2, I can have this one. Okay, the second derivative, because we'll be dealing with second derivative often. So minus 4, then we have first derivative dy dx. Okay, then we have plus y cubic is equal to 4x. So, first equation, what the order of this differential equation? You have to identify what the highest derivative. The highest derivative is what? Is second derivative. Again, we say that what the degree, what the highest power. So the highest power of this differential, the highest power of the highest differential derivative is 1. So degree is 1. Okay, so it's a second order, and then of what is second order degree of 1. Then we come. Does these equations obey the first condition? What does the first condition state? the highest power of any dependent variable present in the ordinary differential equation must be 1. Do we have any dependent variable in this differential equation? The answer is yes. Where that dependent variable. Don't say that this, okay, this is the dependent variable, but this is the differential derivative, this is the differential derivative, this is the function which we call the dependent variable. So the dependent variable here, the highest power is what? Is 3. Is 3 equal to 1? No. 3 is not equal to 1. So 3 is greater than 1. So we say otherwise, if a differential equation does not obey, means if the differential equation does not contain a dependent variable of the highest power of 1, then we consider or classify it as what? Non-linear differential ordinary differential equation. So this one we classify it as what? It is second order. It is second order non-linear. It is second order non-linear ordinary differential equation of what? Of degree 1. Degree 1. So then that's the first condition. Ladies and gentlemen, let me teach you the second conditions to classify whether the differential equation is linear or non-linear. So the second condition now we can keep on focusing between the what? So you say that for the ordinary differential equation to be classified as linear differential equation. Linear differential equation. Then it should not contain any product between dependent variable and the independent and the differential derivative. Otherwise, the ordinary differential equation is classified as non-linear ordinary differential equation. So these are the simple conditions also. We say that for the ordinary differential equation to be classified as linear differential equation, then it should not contain any product between what? Dependent variable and what? Differential derivative. If this happens, then we classify the differential equation as what? Then we classify the differential equation as non-linear ordinary differential equation. So let me give you a related example. So this will be example 3 for the concepts of condition. So you can have this 30 derivative dy dx cubic, then minus 4 dy dx, then plus 3 y dy dx square is equal to 0. So analyze this differential equation. The first classification, is this differential equation partial differential equations or ordinary differential equation? The answer is what? Ordinary differential equation. Why? Because it contains only single dependent and the independent variable. Again, what the order of this differential equation? So you have to check what the highest order. So the highest order in this differential equation is what? The third order, the third derivative, right? The highest order. So the highest derivative is the third derivative. Then what the degree? So the degree, you have to check the power of the highest derivative present in the differential equation. So what the power of this highest derivative? So the power, it is what? So the power, it is 1. So remember that this is exponent. So it is exponent of 3. Okay? So that's the case. So again, we say that what the degree? So the degree is 1. So is it linear or non-linear? Is that ordinary differential question linear or non-linear? So ladies and gentlemen, I can pause the video and then try to answer that questions yourself. So the answer is, remember that we are checking the first of all, did this differential question obey the first condition? Yeah, because the first condition, we say the highest power of any dependent variable present in the ordinary differential question should be 1. So we have dependent variable, we don't have a dependent variable at all. So it means that it's already obeyed the first condition. So the second condition. Then the second condition for the ordinary differential question to be classified as linear differential question then should not contain any product between dependent variable and differential derivative. Do we have any product? Yes. Here we have a product between the second differential derivative and the dependent variable, which is 1. So this is not acceptable. So if we find this one of the terms of the differential questions containing or disobeying this condition, then we classify the entire differential question as non-linear differential equation. So this one, we say that it is what? So we start with order. It is third order. Okay. Let's say the ordinary differential equation of what? Of which degree? Of degree 1. But it is what? Second order, non-linear. So here I forgot, non-linear. Non-linear ordinary differential questions of degree of 1. Degree of 1. Okay. Then you can have example 4. You can have example 4. So example 4, we say that we have y, okay, minus 4 y double dash plus y is equal to cos of x. So what the order of differential question to second order? What the degree is 1. So you can have even maybe a highest degree, which is 3. Okay, 3. So what the degree is 3. And then is it linear or non-linear? So you have to check. Did this obey the first condition? Yes. Do we have any independent variable? Yes. What the highest power is 1. Then did this obey the second condition? Yes. Do we have any product between the dependency variable and differential derivative? No. So it has obeyed what? The first and second conditions of the ordinary differential questions to be classified as what? As linear differential questions. So this one we classify it is what? It is second order linear ordinary differential equation of what? Of degree what? Degree 3. That's the answer. So it means that I'm building, remember that what I'm doing actually, whenever we are building the foundations, we build one layer on top of the other layer. So I've built the foundations in your mind about classifications, about types of the differential question. So I've been building several times and build it and remind you. Also, I told you the concepts of order. I told the concept of the degree of differential question. Now I'm teaching about the concepts of linear and non-linear. So I'm still building the foundations of linear and non-linear on the previous foundations, on the previous layers of the foundations, which is order, degree, types of differential questions, etc., etc., etc. So, ladies and gentlemen, let me present to you the last condition which the differential questions has to obey for it to be classified as what? As linear differential question. But whenever that we are classifying any given differential questions as linear or non-linear, you have to check all the 3 conditions. So for this one, I've tried my level best to avoid them. So it means to give you example of differential questions which disobey the 3rd condition, which I haven't taught you yet. Do you get my point? So even here, I try to give examples which do not disobey this second condition, which I didn't teach you yet when I was teaching you those two examples. So then we say we come to the third condition. So we say that any ordinary differential equation is classified as linear if it does not, if all of its differential derivatives, if the power of all of its differential derivatives is 1. Otherwise, it's going to affect the entire differential equation. So otherwise, the ordinary differential equation is considered as 1, as non-linear differential equation. Non-linear ordinary differential equation. So that's the case that we have. So any ordinary differential equation is classified as linear ordinary differential equation if the power, this is E, if the power of all of its differential derivatives is 1. Otherwise, that differential equation we classify it as non-linear differential equation. That's the case, and this is W. So excuse me, I'm trying to construct the letters as well as I can. So let me give you an example, and then you realize that example 4 is not, when we consider the 30 conditions, then it's not a linear differential equation. So example 5. So example 5, what do we say that? We say that we have y cubic, then minus 4 y double dash, plus 3y is equal to d power x. So it is a linear, or before even asking ourselves the questions of linearity, we have to ask ourselves, is this differential, is this ordinary or partial differential equation? It's what? So this is ordinary differential equation. What is the order of that differential equation? The third order. What the degree? The degree is 1. Is it linear or non-linear? First of all, we have to check it. Did it obey the first condition? The first condition, do you have any independent variable? Yes, we have it, is 1. So it's lowercase 1. What the highest power is 1. So it has obeyed the first condition. We go for the second condition. Second condition is saying that we don't, it means for the ordinary differential equations to be classified as linear, then there should not or it should not contain any product between dependent variable and differential derivative. Do you have any products between y and any differential derivative? No. So it obeys the second condition. The third condition, any ordinary differential equation is classified as linear if the power of all of its differential derivative is 1. So here it is. What the power of this differential derivative is 1. What the power of this differential derivative is 1. So then we say that it is third order ordinary differential equation of degree 1. So it means that with these conditions that we expect all linear differential equation to have a degree of 1 from that condition. And then if we come back to example 4, what the highest, what the power, the highest derivative, what the power. So the power of this second derivative is 3. So according to the third condition, it makes these differential equations to be what is non-linear. So in case that you want to make it linear, so we have to eliminate the 3, and hence we have to make it 1. In case, it means you want just to have one example of linear and one example of non-linear, right? So even sometimes can be given questions and then can be asked yourself as a mathematician to recommend what should be done. So example 6. So example 6, we can have this one. minus 7 dy dx power 2 plus y is equal to x squared. Is this partial differential equations or ordinary differential equation? The answer is ordinary differential equation. It is, what the order of this differential equation? It is second order. Why it's second order? Because the highest derivative is this. Then what the degree of this differential equation? The degree is 1. Okay. Now this differential equation obey the first condition. So let us check. The first condition, we have to check the presence of what is dependent variable. Yeah, we have a dependent variable. Well, the highest power is 1, which is correct. So it has obeyed the first condition. Then, does example 6 obey the second condition? So we have any product between the dependent variable and differential derivative? No, we don't have any. Then, does the example 6 obey the third condition? That all the powers of the differential derivative should be 1. All the powers of its differential derivative should be 1 or must be 1. Must be 1. So it's a condition. So what the highest derivative, what the power of this second derivative is 1. What the power of this first derivative is 2. Right? So then we say that this is second order. This is second order non-linear ordinary differential equation. Degree 1. What it makes these ordinary differential equations to be non-linear? This power. For that degree, for that differential coefficient, but it's not the degree. Because just the power of the first differential derivative. Alright? So you have to keep on enjoying. Do you have any question, please? Because I want to know if you have any question before I give you some questions which can help you. So it means that when you'll be classifying or you'll be answering questions in a test or in a quiz, then ladies and gentlemen, you have to make sure that you understand the concept and you have to make sure that you remember all of these conditions and use them to make decisions and classifying whether the given differential equation is linear or non-linear differential equation. So this is a common concept. This common concept, you'll find so many questions which actually that will be testing you on your comprehensions concerning about classifications. So you might be given 2 differential equations and then be asked that to classify. So you should not be worried about how try your level best to have evidence and to mean that to state as well as you can the correct responses. Okay? So this is the very common concept that you encounter in different aspects of answering the questions of differential question. So you have to expect this kind of the questions for you to enjoy. Because you know that once you have these examples, you may enjoy the beauty of learning ordinary differential question the rest of your life. So let me teach you these two examples, and then I will end this lecture 2. So this is example 1. State the order and state the order and the degree of ordinary differential equation below. So we have A. This is dy dx plus 3 dy dx plus 2y is equal to 3t squared minus b to xy dy dx plus x squared minus y squared is equal to 0. And C it is dy dx plus twice xy is equal to 4x cubed. So this one will be your homework 2. I'll do example 1, Roman A and Roman B, then we'll do the Roman C, right? So interesting. So solution. Solution. So to remember that I told you the order of differential equation is determined by using the highest differential derivative present in the differential equation. So if you start with Roman A, you have to check the given equation. We have how many differential derivatives? 2. This is second differential derivative, this is first differential derivative. Between the first differential derivative and second differential derivative, which is the highest? The highest is the second differential derivative. So it's a one that is going to make decision. So you say that you can say that the second derivative or the second differential derivative plus dy dx, okay, plus 2y, this is equal to 3t squared, 3x squared. 3x squared. So this one is what? Is second order. The second order of what? Ordinary differential equation. You are not asked to classify whether it's linear or non-linear, so don't answer the question which you have not been asked. It's a second order, but you have to write maybe in long terms because it's the abbreviation. The second order, ordinary, if it's an exam, ordinary differential equation of degree what? What the highest degree of this? It is 1. So degree of 1. That's the answer for that question. So B, we will be given this equation. This is ordinary differential equation. It's what it contains only one differential derivative, which is first order, and this the one that will determine the what both. This differential derivative determines both the order of differential equation and the degree. So you say that this one means twice xy. You can also write in this way, twice xy, then y single dash, then you have what? Plus x squared, which is independent variable, then minus what? Y squared, which is in the dependent variable, and is equal to 0, is what? Is none. Is what? Is first order. I told you that in case of exam, you write the long terms of ordinary differential equation of what? What the degree of 1. Then you are done. Right? Are we together? Are we together? So ladies and gentlemen, let me right now present you the second example, which will be the last example for lecture 2, example 2, plus 5, the following. These are the exams questions, the following differential equation, as linear or non-linear. Non-linear order differential equation. So let me give you so it is second derivative plus twice plus 5 first derivative dy dx plus y squared equal to 0. Then B. So you have to remember all the 3 conditions that I've taught you previously. dy dx plus y is equal to 0. Then C, you have y dy dx squared plus 5y dy dx plus y is equal to 0. Then you have D. I want to give you 5 examples or 5 questions. We have the first derivative for the first derivative plus x squared plus x dy dx is equal to x e power x. Then on A, you are allowed to stop the video and try this question on the rough paper, and then you check the answers. So it's not mandatory for you to listen how am I going to solve, because you know the answers of all of these questions. Okay, so we have 5 from A to E. I'm going to answer some of them. So I will answer this. Okay, I will answer that question. I will answer this one, but this will be a homework. And then I will answer this. So this will be a homework 2, and this also will be your homework. So we answer Roman A to Roman I will answer Roman A and Roman B. Yes, it'll be enough for you to get the general concept of all of this stuff. I'd like to invite you in advance in the next session, which will be lecture 3 of differential question. So you should not miss it. You have to make sure you don't miss it. Okay, don't miss it. So solution. Solution. So from an A, we have to classify it whether it is linear or non-linear. So first of all, we have to check this. Is this partial differential question or ordinary differential question? It's ordinary differential question. You need to obey the first condition. What the first condition states that if the dependent variable is present in differential question, it should have the maximum power or the highest power of 1. So if you analyze this, the differential derivative, this the a dependent variable, which is y squared. So because the dependent variable, what the highest degree is 2. Is 2 equal to 1? No. Between 2 and 1, which is highest? The highest value is 2. So it means that for Roman A, we say that it is what? So we say that you can have y double dash, you can write in this abbreviation plus 5, y single dash, and then plus y square is non-linear ordinary differential equation. But you will have to write in exam, you have to write the long terms of ordinary differential equation. That is N. Then we go for D. For D, it means that we have, this is the first derivative. So we have to check, did it obey the first condition? Do we have any dependent variable at the function? No. So we go for the second condition. Do we have any product between y and any differential derivative? No. We have a product between x. So the product between independent variable and differential derivative is allowed. You have to note that. So this is allowed and this is allowed. But if this x is replaced by y, it's not allowed. It makes the entire equations to be, the entire differential equations to be what? Non-linear. So it is first order, so this one is what? So we say that y tetra dash means y, or the first derivatives of y, plus x squared, then y cubed, then plus x squared, y double dash. No, y single dash. This is equal to what? X e power h. So this one, we call it is none is linear. To obey all the three conditions is linear. Linear. It's linear ordinary differential equation. Yeah, wow. So this is the end of the lecture 2 right now. I know that you are so happy and you have got so many materials that will help you to go through. I thank God who have created me in his own image and likeness. I thank God who have given you opportunity to join me. I'll let you invite in the next lecture, which will be lecture 3. Then now I'll be teaching you how we can form a differential equation from the given solution. That will be the next concept. So you have to make sure that you should not miss it. Again, I ask you that to share this contents with your classmates or some of your previous classmates who are studying other engineering and scientific institutions. Okay, so you can also remember that to subscribe. So you have to make sure that you remember that to subscribe. Okay, on this means that you have to remember that to subscribe on this left side, right, of the video. And remember also to like and dislike the video, and then you have to make sure that you share these contents with anybody who is in your environment, because this is the gift for the Tanzanians. So may God bless you. Please tell me in the comment sections also you're enjoying this content from which country, and hence how do you find that they're helpful, and what are the miracles that you have experienced once you've begun to believe about this great work that we are doing here under the guidance of God. So I ask you to keep praying for me, and also I'll be keep praying for you. See you in the next lecture when God gives us chance. So may God bless you abundantly and see you then.